Uploaded. All right. So, part 2. All right. Where were we? So the text-to-speech board. We're gonna dive into the main operating system here in a minute, but I wanted to follow up on what I was saying with this. So the library I use, if we open it in Visual Code Studio or Visual Studio Code, this is what the words actually look like. They're saved as external constants. And then the program mem has these hex lines, and you can see for each word, and he's got quite a bit of words here he can say. This is just one of those vocabulary libraries as well. But for each of these words, there's a string, a hex that follows it that actually makes the word, and they're quite long. So what I've been doing is taking, because there are words that are missing, like there's a lot of words here, but there's a lot of words that are missing when you go to spit out a sentence. You need a this and you need a that, and you have a and you have an or. So it doesn't quite come out correctly, which is why some of the things that he says are kind of spotty, I guess you could call them, broken, which is still all right because it fits with the theme of what we wanted them to sound like. But what I've been doing is I've been breaking these down. I've been making new words. You can add a new external constants to this list and call the function whatever you want, and you can make new words with the hex pieces from other words. So I've been making a list and trying to figure out which of these segments respond to which sounds and which parts of the words and how it's used, and that's how I've been doing that. This is Visual Code Studio, and I like using this for editing C files and .h files. But I also use another piece of software called Notepad+, which I'm quite fond of. So if you don't like just working within the Arduino editor, there are a lot of options out there. So that's what these are calling when we call for a speech. And eventually this will get polished up. I'll replace the voice.say functions. These are all just kind of temporary stuff at the moment. The next version of this, it'll have the command. Well, I'll use what's it called? An array to set up options so that when we send the data to this, we'll send it similar to how we're doing the position data for the face cam. We'll send a string of data like that to the TTS board, and one of those will be a variable for what the voice.say says, and that'll reduce a lot of the code required for this and allow us to use a lot more of this library by addressing one word at a time. That way, instead of having to do these pre-made sentences in pre-made words this way. But this works. This is I guess you could call this like a lazy way of doing it, because it I don't know. Anyway, on to the main program. This is the pasty resistance. So I'm gonna go over how this is structured again. This tab has all of the files for his eyes, and in here I have it drawn out in binary 32 by 32 bit. That's a static constant unsigned character in program mem, and this is what the eye looks like when it's drawn on his OLED screen. So you can see the zeros are the pixel is off and the ones are the pixel is on. And as we scroll through this, you'll see the different shapes for the different eye animations. And then at the very bottom of this, we've got the code that we call when we draw his eyes. And this is sorry, I just got a weird text that I had to read. Whoops. People keep photo bombing my videos. I'm not starting over again. We're running with this one. This is what we call when we draw his eyes. So the main program is structured with a lot of different things. One of the things that I keep note of is I keep notes of the I2C address bus, because I have a lot of I2C devices. So everything that's on that bus has its address recorded here for quick reference. And I have that in the note file too. These note files are really useful. Current version, you can pause it and read all that. That's everything that we've added and subtracted and modified in this current version here. I'm not going to read through it, but you can pause the video and read it if you want. On here again, I have the ITC addresses. I also have reference information for the infrared package. This is everything that's required to make him play laser tag and interface with the laser tag equipment that we have that we use. This here is actually the code that is sent by our laser tag set, and it spews off the end down there. I'm not going to show all of it. I also keep pinouts for things like the power couplers and which arms are connected to which pins on the servo SSC32 controller. I have a complete pinout for the ESP32 typed out in the notes here and what's connected to what pin. This is really useful for when I want to make a change, either to add or remove a component. I know where things are already connected, and I can always quick reference this if I'm throwing down some code to make something turn on or off and I can't remember the pin, which happens quite regularly. A complete hardware list, and then we get down here and all the functions. So the way that I built Crash's OS is I had a general idea of the various things I wanted him to be able to do. So I started with one function and I wrote that function out, and I do that in his main loop here. This is where the main loop starts, and then we have the numbered. These are like modules, and you can copy and paste these, and this is where the loop starts. So the first thing he does is he'll check the switch. Oops, let's fix that. Then he goes on to balance his body, then he checks the Tamagotchi stats. He's still an alarm clock, so he does the clock functions. And then, because those are all priority, they happen first, then he'll check to see if anything's been said to him. And from here, I can make new modules, which I have a bunch down here that I've used for testing. I can just copy these out of this commented section and paste them up here and then work on it. And then when I'm done, I can cut it and then paste it back down into the commented section. And it allows me to work on those different functions, but not have them run if I don't want them to run. So this is how he's structured, and that's how it works. And at the bottom of the main loop, it does a couple of things. It just updates the LCD on his chest with the current variables, and then we got a bunch of things that increment at the end of every loop and some serial prints that spit out information for me. And then beyond the end of the main loop, we have electronic limbo, and this is the beginning of the void function, and we'll get to that here in a little bit. First thing he does when he runs, after we include all of the libraries which are used to make him work, which is quite a bit, and we've attached all the objects that need to be attached, which is also quite a bit. Again, notes. Keep notes on everything and what everything is. It's super important if you're anything like me and constantly forget what you're working on or what you worked on yesterday, or if you go weeks between working on a project. Next, we move on to definitions. Again, pin assignments, integers, and other variables for everything that he can do that's required to make him do all that stuff. Default values for various things upon boot up. And then the setup. So when he boots, one of the things I wanted with him was that display on his chest, and I really liked the idea when I was first building him of having a boot screen that came up like an old computer, and it told you what it was doing, like when Windows used to boot, or the old Apple computers used to boot. So as he runs through his setup here, one of the first things that it does after setting up the serial ports is the LCD, and it'll spit out onto the LCD that it's loading the operating system. And I just kind of cheated with it. If you've ever taken apart a copy of Windows NT, they do exactly the same thing here with a bunch of delays and a bunch of updates to the screen in order to simulate a loading bar, why it does everything. Most importantly though, without having him hooked to a computer, this tells me what he's doing during a boot up on his own display in case something happens and he doesn't boot up fully, I can diagnose in the field without a PC and get a general idea of what's going on with all of that. Let's see, here's the serial wombat section. Again, the wombats, I love them. They're awesome. This is how you set them up. I mean, they're serial ports you can throw on the I2C bus if you use a lot of serial devices. I haven't had any issues, really, with speed as far as addressing any of these modules and sending data back and forth. They've worked pretty well. So this is how we use the wire library to send commands over the I2C bus to the soundboard. And these are all freshly converted. I'll polish this up a little more here before too much longer. So like we were talking about with the notes, right, one of the things we did in this version was we installed the new YX5300 sound card to replace the old one, and we changed all the commands from the old card to the new YX5300 commands. And if we go back, we can see that we started using that old sound effects card in version 1.3. So every time I add a function or I add a device, sometimes I do a couple of different things in one update, but I save it and I make a new version number, and then I do the update that way. So as that version grows, so does his capabilities, which is kind of cool. And then at the end of setup, it'll spam out the command for him to say that he's online, which he does, and then it starts the loop. So yeah, anytime I add something to him, I write a new module and I paste it in here, and I flesh it out here in the main loop. And then once I have it working in the main loop, I'll copy it or cut it, put it into a void function down below in the jungle, and reference it from up here. And a lot of these things that he can do, I keep note of as well. Well, not a lot of them, all of them. So here we have all the memory related functions organized. We can call to clear the EEPROM to save the state, or to, gotta make sure you spell check all your shit, man, or you can load it. And these two are used in the death and shutdown functions, and then the boot cycle calls the load save. And then we have standard functions like touching them and shutting down and reading the light sensor, listening to things. Eyes, get position, reads the position information from the GPS. Same with checking his battery level, that just reads the voltage on the battery pack. And same with the compass, you can imagine how that works, as well as the rangefinder. You've got commands to turn different parts of the machine on and off. These three are the newest ones I've been working on, and I've been held back on doing that stuff, the really cool stuff that we all want to see, where he reaches out and picks things up and stuff, because I have power issues. My regulators don't put out enough amperage, so when he starts bopping along, he tends to suck batteries pretty dry, and I get to do maybe 45 minutes worth of work, and I don't make a lot of progress in that 45 minutes, and then I gotta wait a few hours for the batteries to be charged again. So that's why development's been stalled. I have some new modules coming, but they still haven't arrived. These are his clock related functions. He can speak the time, he can synchronize the time on his chest with the real-time clock that's installed in his head. Get clock is used to draw or write all the clock information on the LCD on the chest, and then the alarms is the alarm clock features. Game functions, we've got laser tag and the guessing game, and then these are both actions that he can take during laser tag, one of which is a machine gun where he does a sweep, and then the revolver where he's supposed to use this function, where is it at? Track object, which will query the head and see if it's got a connection on an object, and if so, then it'll use the data from whatever it's tracking to point the arm at whatever it's tracking, and then it uses the revolver command to fire a couple of single shots, whereas the machine gun one just kind of spams out infrared shots across the room. So two very different attacks that he has from when we're playing laser tag with him. Visual related functions, we can talk to the head generally right now and just get a set of information from it. What this does is it reads the information from the head, whether or not it's tracking an object and where it thinks it is and how far it thinks it is, and just spits it out on the serial bus. Touch object, track object, and grab object are all going to be voice-based actions, which means we'll say something to him or ask him to do something, and he'll trigger these. And as you can imagine, it'll be to touch, track, or grab whatever we have in our hand. And then some more arm-related functions here, powering individual arms on and off. He can do a double-handed chest pump, and then he's got his disco dancing that he does. He can also wave. Arms at the ready, puts his arms into a neutral position on the body before powering them off. That way he's not shutting down with a hand way out to his side or dragging an arm behind him or anything like that. Also in the notes, we keep track of the memory map for the EEPROM that's installed, some personality notes, and that kind of wraps it up with a bunch of other random stuff thrown out throughout here too. Don't forget to continue development, folks. You know, even if it's an old project you haven't worked on for a while, if you got an idea for it, keep it up. I've got to pause this video now for part 2 because I'm over my limit, but we will work on this tab in part 3.